So when this is, I've got 3 different vertical lines there. I've done 3 tests on this graph. So right here, this line here cuts it in one spot. It only touches it in one spot, so that means the graph is a function. So a non-example would look, or could look like this. So if I have a graph that goes like that, I don't know how you ever would, but if you have a graph like that, if I draw my line here, it only cuts it in one spot. So that part of the graph is a function, but if I drew the line here, it cuts it here and here. The whole graph is not a function. So if I have a graph going like this one, if I drew the vertical line, it cuts it there and there, so it's not a function. So these are not, yep, and that is a function. Okay, so anytime a vertical line cuts a graph and touches it in 2 spots, you no longer have a function. So it says a very important feature of the parabola that results from a quadratic function is where it touches or crosses the y-axis. These are the x-intercepts of the parabola. What is the y-intercept? Add an x-intercept. Yeah. So it says when the graph crosses the x-axis, so if I look at any of these spots here, so here it's crossing the x-axis, here, whoops, that's actually not my graph, there and there. What do you notice about y at those spots? Right, y is always 0 at those spots. And that's how, if you remember from last unit when we were doing the quadratic functions and we were graphing them, when you're supposed to find the x-intercept, you let y equal 0. Yeah, and you would have done it last year too. So it says, therefore, to find the x-intercepts of a parabola, we can set y is equal to 0 or f of x equals 0, and then solve the equation. So you did those before. We're going to do more of those. So it says, when y is set to 0, we call the question a quadratic equation instead of a quadratic function. So quadratic function is when it equals that f of x or y. Quadratic equation is when it equals 0. So here's just 2 examples. Quadratic function, you have f of x equals x squared minus x minus 6, or y is equal to quadratic equation. We replace the fx or the y with a 0. Y is your 0. You're saying, yeah, yeah. Well, the y is relevant because it helps us find our x values. But the only relevance it has is that it equals 0. So the x-intercepts of the parabola are the zeros of the quadratic functions. So when you're doing questions in your book, it won't always say find the x-intercept. It'll say find the zeros of the function, or else they'll call it the solutions or the roots. All those mean the same thing. So the zeros, the solutions, and the roots all mean x-intercept. Where are you? Well, it's the bolded things on your sheet. The zeros, solutions, and roots. So how many x-intercepts can a parabola have? Right? Right, it could have, we'll start with the smallest amount it could have. So it could have 0 x-intercepts. For a graph to not cut or cross the x-axis means it either has to be above it or below it. You can open up above it. It could be down in this spot here. Yeah, as long as it doesn't actually cross that x-intercept, so then it would have 0 x-intercepts. Oops, that was a little big. To have 1 x-intercept then means that it's going to have to touch the x-axis. It can't cut it, it has to be right on it. So it could be right here. Yep. Vertex is exactly on the x-axis. And then this could be slid over anywhere along this x-axis, or it could go the other direction too. 0 x-intercepts. So for there to be 1 x-intercept, it has to just touch it. So what will it look like to have 2 x-intercepts? Right. Your vertex is going to be above or below the x-axis, and it's going to go through it. So it could look like this. Or it could look like this. So it's cutting it here and here, or here and here. So if that's how many x-intercepts we have for your quadratic function, how many zeros can there be? 2, 1, 0. Right, same thing, 0, 1, or 2. Because remember, 0, or the zeros of a function, means the exact same thing as x-intercept. So then how many roots or solutions do you have? Possible. Right. Okay, so it says one method we can use to find the zeros of quadratic functions is to complete the square and turn standard form into the vertex form and then graph it. So one way is put it into that vertex form like we did last time and then graph the function. Another way to graph a function in standard form is by using a table of values. So we did both of those in the last unit, so this is nothing new or earth-shattering from what we did before. So the example says, what are the roots of this equation? Is this one in your book or no? Okay, I don't know why. X squared minus x minus 6 equals 0. So it says change the quadratic equation into a quadratic function. Well, this one's already done. It equals 0. Make a table of values and then graph the function. Quadratic equation equals 0. Yeah, oh, sorry, yeah, this one isn't. I was reading it wrong. So step number 1 would be to do this. X squared minus x minus 6. So we put that y equals to make it a function. Step number 2 is make your table of values. And then start solving them. So if I started at -4, work is what? Yeah? It's not a perfect trinomial square, if that's what you mean. I just picked it. So if I do the math for this one, I have, well, I should have wrote that in here. -4 squared minus -4 minus 6. So I have 16 plus 4 is 20 minus 16 is 14. And then I keep going for 2 or 3 positive values, 2 or 3 negative, and you always throw in the 0. So negative 3 squared is 9 plus 3 is 12 minus 6, 6. Now for the rest of these, I'm just going to put in the values, but that's the steps I would use to solve them. So negative 2, when I substitute in there, gives me a value of 0, y value of 0. Negative 1 is negative 4. It doesn't go down arithmetically, right? Right. 0 is negative 6. 1 is negative 6. 2 is negative 4. 3 is 0. And 4 is 6. Yeah. Remember, in quadratic function, your graphs, well, because it starts to repeat itself, right? Yeah. When you substitute 0 in there, I have 0 minus 0 is 0, so I'm left with negative 6. When I substitute a 1, 1 squared is 1, minus 1 is 0, minus 6. Just the way the math works out for those. And when you're doing a table of values, you want to see your values repeating. It's going to reach a point and then your numbers repeat. Sure they are. Negative 6, 6, negative 4, 0, 0, 6, 6. And if I did 5, I would have 14. No, 3 is 0, 4 is 6. I don't know. You'd have to try it and see. So step number 2, once you've got your table of values, you graph your points. So negative 4 and 14 is going to put me up here, so I'm not going to bother with that one. Negative 3 and 6. Negative 2 and 0. Negative 1, where it is negative 1 and negative 4, so it's down here. 0 and negative 6. 1 and negative 6. Yep. 2 and negative 4, and let me just put this, where am I? 3 and 0, and then 4 and 6. Yeah. Question? Okay. Well, our vertex, we didn't calculate it. It would be a fractional amount. Because if this is where the repeat is in between negative 6 and negative 1, that means my vertex is between 0 and 1. Okay, so my vertex would be somewhere in here. Well, so now when I go to graph this, it's going to come down. Whoops, pretend that's straight. And then it'll start curving up. I'll do this. There, that help? Okay. Your vertex, it'll probably be 0.5. Yeah, because it'll be somewhere right in here. So step number 3 says note any x-intercepts. These are the zeros of the function and roots of the equation. So if I either look at the graph or on the chart, this, I'm going to use a different color. This one right here and this one right here are the x-intercepts. They're the zeros of the function, so that would be my solution to this equation or to this function. So those occurred at -2 and 3. And if I look at my chart, at -2, y equals 0, and at 3, y equals 0. So by definition, those have to be my x-intercepts because y is equal to 0. Yeah, 2 is the chart. So number 4 says, or step number 4 says, check the solutions. So you check the solutions by substituting -2 into the equation and then 3 into the equation. So -2 squared is 4. Negative times a -2 is a +2 minus 6. Y equals 0. Yeah. Your y should equal 0 for your x-intercepts to be right. So then you check the other one. Y is equal to 3 squared minus 3 minus 6. So that's 9 minus 3 minus 6, which is 0. Listen. So example 2 says, what are the roots of the equation -x² plus 6x equals 9? So we're going to follow the same steps as we did in the one above, but instead of doing the table of values is good, but it takes a while to get your answer. We're going to use the vertex graphing form. Okay, so step number 1 was to put it so that it is a quadratic function instead of a quadratic equation. Right, so we need a y. Whoops. But we also have to bring this 9 over. We have to bring it to this side of the equation, so that means it's going to become a negative. Okay, completing the square. The first step was you take your first two terms and you put brackets around them. Yeah, this is what you did last time. So now I have a negative in front of my x². I can't have that. It has to be a 1 in order to complete the square. So I GCF a -1. This becomes x² minus 6x minus 9. Oh, I should put my blanks in there now because that's what we had done. So plus blank minus -1 times blank minus 9. Because remember that -1, if you GCF it here, you have to multiply it to the blank on the outside. So then our step was take our middle term or our b value, -6 divided by 2 leaves me with a -3. -3 squared is 9. So x squared minus 6x plus 9 is my perfect trinomial square that I was trying to get. So it means my factors are x minus 3 all squared. Then I have negative times negative is positive 1 times 9 is positive 9 minus 9. So it's just a 0. You could write it in as a plus 0 if you want, just to help you. Right. So from here I know my a is equal to negative 1, p is equal to 3, q is equal to 0. So my vertex is at 3 and 0. Is my graph going up or down? So our graph is going down because a is negative. So that means when I go to do my count, I'll go over 1. And, but instead of going up 1, I go down 1. Over 2, down 4. Because it's whatever my overs are squared. And then over 3 will be down 9. So with that information there, I can graph. So my vertex was at 3, 0. And then do my over downs. Over 1, down 1. Over 1, down 1. Back to vertex all the time. Derek, you with us? Over 2, down 4. And then over 3, down 9. Connect your dots. So by looking at this graph, my x-intercept is what? 3, 0. Which also happens to be my vertex for this one, and it's just a coincidence that's the way it worked out. So my x-intercept equals 3. If I check my solution, so my left side, right side, from the original equation, this is the check. Left side of your equation. My equation was negative x squared plus 6x equals 9, right? Yeah. So you put your left side of the equation there, you put your right side here, and then you substitute in your value. So I have negative 3 squared plus 6 times 3. So this is negative 9 plus 18, which is 9. This side equaled 9, so I'm right. When I brought it over to the left side, it minus. In my original equation, it was equals 9. Pardon? Yeah. Yeah, only the x. In this one, that negative wasn't in a bracket. Okay, next example. It says solve 2x squared plus x plus 2 equals 0 by graphing. And they want said to solve a quadratic equation means you find the roots, if any. In this example, graph the corresponding quadratic function using a table of values. So this one says use a table of values, so that's what we're going to do. So step number 1 for the table of value method is to put it, why is it giving me an eraser? Put it back into quadratic function. So that means I drop the 0, add a y. Yeah, and it'll depend on your number too, because sometimes if your equation here is like a 10x squared, well, you might not want to go to a negative 3 because you're going to end up with a negative 900, right? So you just have to judge looking at that what you can do. Sometimes you might need to do a fraction, but after you try 1 or 2, you'll figure out which numbers to use. So set up your table. I'm going to start at negative 3. So y is equal to 2 times negative 3 squared plus negative 3 plus 2. So that's 2 times 18, so 36 minus 3, 36? No. That should, I doubled it twice. 9 times 2 is 18. Whoops. No. Okay. So 18 minus 3 plus 2 gives you 17. Yes. No. Because you put 2 times negative 3 all together. It should be 2, then bracket, negative 3, bracket squared. Because the only thing being squared is this negative 3, not the 2. 17, actually. Yeah, 18, and then your answer. So if you do this for negative 2 squared is 4 times 2 is 8, minus 2 is 6, plus 2 is 8. So now I'm just going to give you answers. Negative 1 is 3, 0 gives you a value of 2, 1 gives you a value of 5, and then 2 gives you a value of 12. So I've got six values that I put in there. I haven't come up with a vertex. My numbers aren't repeating, but if you look at my numbers, my values went down. I went 17, 8, 3, 2, and then my numbers start to get higher. So these are getting lower, and then they start from here, they start to get higher. So what that means is in between, somewhere in between 0 and 1 is going to be my vertex because my graph was going down, 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 and then it started to go back up. My y value started to get bigger. Well, because between 0 and negative 1, my values were still going down. I was going from 3 to 2. And then I skipped from going from 2 to 5. So my value went up. So the vertex is somewhere in here. Could be. You could figure it out if you really wanted to. So if I graph these points that they've given me, and that's what you want when you're looking for, when it's not giving you a specific vertex, watch your y values. When the values start going down and then going back up, then you know you've got enough to graph. So negative 3 and 17, it doesn't have it on here, but it's going to go somewhere way up there. Negative 2 and 8. Negative 1 and 3. 0 and 2. And then it went 1 to 5. Where's 1 to 5? No, 2 and 12 is going to be about right there. So if I connect my dots, that's a really bad one, but gives you the idea anyway. Well, all we know really for this one is A is equal to, it's positive. Well, it is. My lines aren't really good. That's when you're doing the completing the square method, though, the vertex graphing. Yeah, this one you can't. Okay? Well, my picture isn't. It should have gone. Because my vertex would be somewhere right here. So my graph should be curving up like this, and then curving like that. Okay? Not my vertex. No, because 0, 2 wasn't a repeat factor. Remember from the last time we did table of values, when you hit a number, so if 0, 2 was, right. So we don't have a finite number for our vertex, which doesn't matter because all this question is asking us is, what are the roots to this? So that means what are our x-intercepts? So what are the roots to this? None, right. So this graph has no x-intercepts. Because the vertex is above the x-axis. And the parabola is going up. Therefore, we say there are no roots or no solutions. Either one of those is right. You could, well, depending, yeah, you could, but you should write it as no roots or no solutions. So your assignment for this was page 215, 1, 2, 3AC, 16, 17, 18. It's on the bottom of your page.